Today in class we're going to do kinetic and potential energy problems practice 2. You're going to be doing the odds. In this video I'm going to go over how to do the evens. Our first problem, number 2, says that the kinetic energy of a bowling ball traveling at a speed of 4 meters per second is 50 joules. Find the mass of the ball. First thing I'm always going to do every single time is identify my variables. I know that in a kinetic energy problem, because I see the words kinetic energy, I have kinetic energy, I have mass, and I have volume. Now I have to try to find these variables in my problem. Kinetic energy has the ending of joules. So I know that I have a kinetic energy of 50 joules. Mass is in kilograms, but it says I don't see any kilograms here, and it says find the mass, so that must be what I'm trying to find. And velocity is units of meters per second. So I know that my velocity is 4 meters per second. I know you're used to the kinetic energy equals 1/2 mv squared, but because we're trying to find mass instead of finding kinetic energy, it means I need to use a different equation. If you recall in our notes that we have the equation mass equals 2 times kinetic energy divided by velocity squared. So this is the equation I'm going to use to solve for mass. My mass equals 2 times, and I'm going to replace my KE with 50. 2 times 50 divided by my velocity, which is 4 squared. I'm going to type the top into my calculator, 2 times 50, and I find out that that is 100. And I'm going to square the number 4, so that's the same as 4 times 4, which is 16. Now I'm going to type into my calculator 100 divided by 16, and I find out that my mass equals 6.25 kilograms. Make sure you have units every single time. Number 4 says which runner has greater kinetic energy? A 56 kilogram or 46 kilogram runner moving at a speed of 8 meters per second, or a 92 kilogram runner moving at a speed of 4 meters per second. I have 2 different runners here, so I'm going to have to do this problem twice. Runner 1 and runner 2. My variables in the kinetic energy problem, right, are KE, M, and V. And I'm going to have this for both of these runners, because I'm trying to figure out who has a bigger number for kinetic energy. Now it's time to identify values. I'm trying to find who has the bigger kinetic energy, so that's my unknown for both. My mass for runner number 1 is 46 kilograms. My mass for runner number 2 is 92 kilograms. My speed or velocity for runner number 1 is 8 meters per second. And my velocity for runner number 2 is 4 meters per second. Time to write out my equation. KE equals 1/2 mv squared, and it's the same equation for both sides. KE equals 1/2 mv squared. And if you wanted to focus on just one problem and focus on the other problem, that's totally fine. Or if you want to do it simultaneously like I'm doing, that works too. You just need to solve this problem twice. So KE equals, I'm now going to replace my 0.5, my 1/2 is the same as 0.5. My mass is 46. And my velocity is 8 squared. I'm going to type right into my calculator. 0.5 times 46 times 8 times 8. That squared means I need to multiply times 8 twice. And when I type this into my calculator, I get a kinetic energy of 1,472 joules. Now time to plug in over here. Kinetic energy equals, and that 1/2 is the same as 0.5. My mass is 92, and my velocity is 4 squared. So what I'm going to type right into my calculator is 0.5 times 92 times 4 times 4. And when I type that into my calculator, I find out that the kinetic energy is 736 joules. And my question is asking which runner has a greater potential energy. Runner 1 has a potential energy of 1,472, and runner 2 has a potential energy of 736. So we know that runner number 1 has the greater potential energy, or kinetic energy, I apologize. Let's move on to potential energy problems. Okay, potential energy problems. I know that my values that I need, my variables, are potential energy, mass, G, and H. Let's see what I know. Potential energy has the units of joules, and look, here's joules, so I know that my potential energy is 294 joules. My mass has a unit of kilograms, so I know that my mass is 15 kilograms. G is absolutely and always 9.8 meters per second squared. And I am trying to find the one variable I have left, height. My potential energy equation, PE equals mg h, but I can't really use this formula right now because I'm trying to find h. So I'm going to use the triangle technique of putting potential energy on the top, m, g, and h along the bottom. I am solving for h, so I'm going to cover up h, and I'm going to see that I have potential energy on top of m and g. So I know that H equals PE divided by M and G. If you just want to memorize this equation, you're totally welcome to do that as well. And then you don't have to do the triangles. Time to replace here. My PE, I said, was 294. My mass, we said, was 15. And G is 9.8. So what I'm going to do first is I'm going to multiply these bottom numbers to get one number, and then I'm going to divide by the top. When I do this math out, I find out that my H equals 2, and my units for height is always meters. Do the next one. Find the mass of a ball on a roof 30 meters high if the ball's PE is 58.58 joules. So my units, or my variables, are potential energy, mass, gravity, and height. It tells me find the mass of the ball, so I am trying to find mass here. Now it's time to identify some values. Potential energy always has the units of J, so I see that I have 58.8 J, or joules. G, we know, is every time 9.8 meters per second squared. And my height is 30 meters. I'm going to use the triangle technique because I'm trying to solve for something I'm not used to solving for. Potential energy on top, M, G, H underneath. I'm going to cover up what I'm trying to solve for, my mass, and I'm going to see that potential energy is on top of G and H. So I know that my mass equals potential energy divided by G times 8 times, to replace, we said my potential energy was 58.8. G is always 9.8. And H was 30. And this is how I'm going to find my mass. I'm going to first type these two into my calculator. And once I get that number, I'm going to do 58 divided by that number. And I find out that my mass equals 0.2. And my units for mass is always kilograms. Alright, last evens. A 0.1 kilogram ball rolls across the floor at a speed of 2 meters per second. Another 0.1 kilogram ball rests on the shelf 1 meter above the floor. Which ball has more energy? This is another problem where I need to solve two different ways. I have one object, ball 1, and I have a second object, ball 2. The tricky part about this problem is ball 1 is a kinetic energy problem because I have something moving, the ball is rolling, and ball 2 is a potential energy problem. I'm going to start by just focusing on ball 1. Kinetic energy, we need to find normally mass and velocity. So I'm trying to find my kinetic energy. My mass for ball 1 is 0.1 kilograms. And my velocity, it's moving at 2 meters per second. Kinetic energy equals 1/2 mv squared. Kinetic energy equals, remember I'm going to change that 1/2 to a 0.5, times 0.1, my mass was 0.1, times my velocity, which is 2 squared. So what I'm going to type into my calculator is 0.5 times 0.1 times 2 times 2. When I do all that, I find out that my kinetic energy is equal to 0.2 joules. Okay? Now I'm going to do the potential energy side for ball 2. Potential energy, we're looking for mass, G, and H. Remember, you will have these formulas on a test. You do not need to memorize them. My mass of ball 2 is 0.1. G is always and forever 9.8 meters per second squared. And my H is 1 meter above the shelf. And I am trying to find potential energy. My potential energy equation, PE equals mg H. Time to replace. PE equals 0.1 times 9.8 times 1. So in my calculator I'm going to type 0.1 times 9.8 times 1, and I find out that this is 0.98 joules. So which ball has more energy? Ball 1 that has a kinetic energy of 0.2, or ball 2, the ball that has a potential energy of 0.98? And the answer is ball 2 has more energy.